So today, what I'm planning to discuss today, we will see the active scenario in Palo Alto firewall. Okay. Before that, because for that I also need one more interface. I need to connect between these two devices for HA3 link. So I will use Ethernet 1/7 as a HA3 link. Okay. So let me go through with the PPT, and after that we will see the configuration part. So meanwhile, I am just starting my Palo Alto devices, so they will boot up properly. If you know, in active scenario, what happens? Both the firewalls are in active mode, and both firewalls basically will do the data forwarding at the same time. Wait, my pane is opening. S- So in device back each other, taking the over primary ownership in the other field. So the thing is, let me tell you. Let's suppose this is a scenario of active firewall where this device is also active and this device is also active. So on these particular inside PCs, whatever, let's suppose we have defined the default gateway of this IP address on few machines, then they will send the data into this way. If we will define the IP address of this interface on few devices, they will send the data into this way. If any of them goes down, then they will send the entire data from the one link only, from one firewall only. This is our active scenario. So in this, both devices in the pair are active, and they will basically processing and forwarding the traffic. We can also achieve the load sharing in that particular scenario. Okay, and they will also have a one HA3 link. Okay, so this, let's suppose this is a HA1, then we have HA2. This link, let's say this is a HA3 link. Okay, so if they want to communicate with each other, they will forward the data through this HA3 link. Let's suppose, so they in active we are having few methods. There is a concept of session owner, and there is a concept of session setup. So session setup is basically responsible for our layer 2 to layer 4 functionality, and session owner is responsible for all the functionality at layer 7. Okay, and how they will basically, how firewall becomes session owner and session setup. So for these things we will see when I will do the lab. I will explain you all these steps. Okay, so when we basically put two devices into active mode, there is no increase in the session capacity. This solution is not increased any kind of throughput as well. If let's say we are using 850 model of Palo Alto, if 850 have a throughput of, let's suppose, 10 GB per second, then it will only able to handle the 10 GB. Okay, not more than that. We can configure active into virtual wire or layer 3 mode only. Generally, we use this kind of setup where we are having asymmetric routing. So we have discussed what is asymmetric routing yesterday, right? So I'm not going into that one. These are the links. So HA3 link basically is responsible for passing the packets between the session owner and session setup devices. Okay, we will see how it works. Now session owner. So session owner is responsible for all the layer 7 inspection, which is like app ID, content ID, threads, all these steps. It evaluates the security policies and logs the traffic. These are the functionality of session owner. So let's suppose if you see they are receiving two packets, right? If let's say for this particular packet, if this device is a session owner, then he will handle all the layer 7 functionality. Or let's say for this particular packet, if this device, become session setup. Then this packet come here, then they will forward this packet through HA3 link to the secondary primary to the active secondary firewall. He will perform all the layer 2 to layer 4 functionality, all the session setup functionality. That's why they will use this HA3 link to exchange the traffic between session owner and session setup. We will have three ways to basically use on the basis of first packet. So the thing is, when any device receives the first packet, who become the session owner. So we will see these things practically. Okay. Now we will have a session setup. Session setup is responsible for all the layer 2 to layer 4 for functionalities. A- Address translation is performed by the session setup firewall. So address translation also done by the session setup firewall. If session ownership is set to active primary firewall, session setup defaults to active primary. Not recommendations, all the traffic will be handled by the active primary firewall. We will see. Okay, what is the meaning of that and everything. Now these are the states. So we are having like active state, then suspended, then passive, non-functional, and tentative. Tentative means they are just syncing the config. Device in recovery from path or link or task failure. Non-functional means it is not functional right now. Due to if H3 link goes down, that time it become into is. So first we will see the floating IP deployment. Okay, in floating IP, what happens? We need to configure one floating IP into this firewall, one floating IP into this firewall. So let's suppose this interface is a Ethernet 1/1. This interface is a Ethernet 1/1. Okay. Then we will configure one IP address on that interface, which is 253. In this interface, we will configure 252. And also we need to configure this floating IP address, like 100 on this one, 101 on this one. Okay, so when we set the default gateway as 100, this traffic go to this device. When we set the default gateway 101, this traffic goes to this device. If this device goes down that time, both the floating IP you start basically, this device starts using both the floating IP addresses and he will basically do the data forwarding. Floating IP address and virtual MAC address move between the devices on failover means floating IP, and the thing is this floating IP also have a one corresponding MAC address. It will also failover. Supports BPN and NAT implementations. So in that case we can configure BPN and NAT. Can we use external load balancers to spread the ac- across the devices? We can also have a basically load balancer for that. So we will see the that floating IP deployment, and after that I will show you the ARP load sharing. Okay, so let me first complete that one, and after that I will go for the ARP load sharing. If you want to learn this on more details, you can just check out the Palo Alto documentation regarding the configuration for both the scenarios. Okay, so what? Let me go to into my topology and let me start my config without wasting the time. Okay, so by default, when we will have when we will start these devices will get the IP address which is 192.168.137.128. So this is the primary one, and 192.168.137.129. If I'll open my, because these both devices getting this IP address from the DHCP server. Okay, but I will change that these IP address, and we will use some descriptive IP address. Just give me a second. Okay. So let me log in on both the devices. And we will see the configuration. We will configure the interface and everything according to this setup. Okay. And only the floating IP I have not mentioned. So that time I will, when we will configure that time we will have a look on that. Okay. So first of all, what I want to do, I want to just change the host name of both the devices. So I will give like firewall 01 domain name if you want, otherwise don't require. Okay. I have changed the host name. Let me also configure my interfaces with the static IP address 192.168.137.115. I'll configure here. These are the basic settings which I need to configure. The two. Done with the config on first firewall. I will commit my changes. I will go into the second firewall. I'll do the same settings here. I'll change the host name and I'll give the host name which is firewall 2. I will change the domain name. Interfaces. Let me just configure the interface. 192.168.137.115.116. Okay. 255.255. 255.0 and the default gateway is 192.168.137.2. Just I'll hit the commit. So I will commit my changes. It is in 99%. Okay, so let's wait. It's have been completed. What this time? Let me just log in with my new IP address. Admin, admin. See, this is the firewall one, and it is also coming 116. Log in on this one as well. Admin, admin. Okay, so now both devices coming up. So now let me start my configuration. So first, what I will do, I will start from network interfaces. Go to interfaces, and if you see as per my topology, Ethernet 1, Ethernet 1/3, then 4, 5, 6, 7. These are I'm using these interfaces as HA interfaces. So let me just change the interface type for all of them. HA, HA, then this one is also HA. 7 also I'll configure as HA. Okay, so I'm done with here. Now I'll go to into device tab. Directly I'll go to into high availability and I'll start configuration. Enable it. I'll give the group name which is 10. Give. This is a active deployment. I select this option active. I will just yes. So I will configure peer HA1 IP address which is IP address of because this is my peer, right? So H1 interface having IP address in this range 1.1.1, right? So peer IP address will be 1.1.1.2, 1.1.2, okay. And the other HA backup IP address is 1.1.2.2 because I am using 1.1.2, okay, dot zero range here. Let me start configuring this interface. What I will configure HA1 here, I will that 1.1.1.1 net mask is 255.255.255.0. Let me copy the net mask. So I will use copy and paste functionality. I will put this one from here for now. Okay. HA1 backup. I'll go there. I'll select Ethernet 1/4 1.1.2.1. Control V. Okay. I'll go to into HA2. HA2 is my Ethernet 1/5 1.1.3.1. Net mask is this transport Ethernet only. Done. And let me go to into HA2 backup, which is my Ethernet 1/6 interface. 1.1.4.1. Net mask is this. Okay. Election. I will set the device priority here 50. Heartbeat backup. I will use management interface. Recommend it and enable the heartbeat. Done. Okay. Now I'll go to into active session scenario here. I'll go to into HA interfaces. I will use Ethernet 1/7. Select this 60. And if you see right now session owner selection, we are reusing first time on the basis of first packet. Okay. Then we will use session setup on the basis of first packet as well. Means first packet means whoever receive a packet, he will basically perform all the layer 2 to layer 4 functionality and all the layer 7 functionality. Then with this, now I need to configure the virtual IP addresses. Okay. So before configuring these addresses, what I need to do, I need to go to into my network tab and I need to also configure these interfaces. So I will go to into this interface. I'll give the name as a layer 3 interface. Okay. I will use the virtual router, which is default, and security zone. This is my outside zone. So I will use here outside. Okay. I will need to set up the IP address here. So in my outside interface, I'm using 192.168.115, right? So I will give this IP address 192.168.0.115/24. Go to into advanced tab. I enable the interface and I also need to configure this management profile where I will allow the telnet, not telnet, SHS, HTTP and ping. These three requests. Give the name MGMT profile. I have configured this interface. Let me go to into that one. Let me also enable the configure the layer 3. This is my inside interface. I'll put the default route, create a zone, and I'll give the name to this zone is inside. IPv4. Here I will use 192.168. 1 dot. What is the inside network? I'm using 192.161.115. Okay. 115/24. In advance, I will just make the interface up, then select the management profile. Done with the configuration in that place. Now I'll go to into the device again. Let me add the interfaces. So I will first add Ethernet interface. Now in this place I need to configure the binding. Okay. I will click over there and I need to give the IP address. So first I will give 192.168.0 dot what IP address I'm planning to use. I will use here 117. This is the floating IP address on my primary active device. Okay, /24. I'm using the type as a floating IP address. Device priority here I will give 10. Here I will give 20. Means for this IP address, owner is the primary active device. I will use this one. Click on OK. Now I will add one more IP address, which is 192.168.0.118/24. Here I will give 20 and 10, which means this device priority 0 means this IP address basically will be active on the primary device. Just remember. 1 minute. 1 minute. Yeah. Okay. So what I can do, let me tell you. So when we have set the device priority 0 and device priority 0, just consider this is a firewall 01, and device priority 1 means this is a firewall 02. This is a like active primary and this is a active secondary. Okay. Now if I have given this IP the 192.160.0.118, and where my priority is lower on device 1, which means this 192.160.118 will be configured on the firewall 02. In the previous what I have configured this IP 192.168.0.117, and I have set the priority 10 and 20, right? So I have set the priority 10 on device 0 and 20 on a device 1, which means this IP address will be configured on my firewall 01. Okay, that's the case. So what I will do now, let me just put the paint here. Okay, I'll configure this one. Will click OK. Okay. Okay, there is invalid address must. Okay, so we have to here need that one slash not slash 24. We need to add here /32. It's a single IP address, that's why. Okay, click on OK. Now let me configure the IP address for my inside Ethernet 1/2. So I will give 192.168.1.117/32. This 117 I want on my first device, so I will on firewall 1, so I will give here priority 0 because priority lower will be preferred, right? So I will give 10 here 20. I will add one more, which is 192.168.1.118. This IP address I want on the secondary firewall. So I will give here 20 in the second firewall I will give the priority 10. So this will be active on a 10. Okay. So that is also fine now. Now what I want to do, if now I'll go to into my second firewall, and let me start the configuration over there as well. Okay, what I will do, I will go to into device, high availability, enable it. Okay, I will enable, give the device priority which is 10, because we have used the 10 here. We don't need to actually use this priority value. So what I will basically configuring this 100 only. Okay, we don't need to change that one. That we will go with the default value. This one I will give the description, active active deployment. So if you change the mode to active to, then all the active passive content will be lost. Are you sure? Yes, I won't. Okay, so if you remember, we have selected this device ID, right? And this one also, this device have a device ID 0, right? So on this device, I will give the device ID 1. And here I will use peer HA1 IP address is 1.1.1.1 slash 32, 1.1.1.1.1.2.1 slash 32. You can see the details here. You can use the slash or you can give the single, it will work. So let me just skip in this way only. I don't want to use slash 32. Okay, 1.1. Now let me start my HA configuration. Before going to that one, I need to change my interface type, right? I'll change that interface as a HA interface 1/4. Also I'll change with HA. I'll do the same thing with HA 1/5, 1/6 and 7. And 1/7, which is my HA interface. So I have changed the interface type HA. Now I'll go to into device tab, and here what I will do, I'll start my HA interface configuration. I'll go to into Ethernet 1/3. IP address is 1.1.1.2. Net mask is 255.255.255.0. I will copy this one, commit, not commit, save. Here I will go, I will select my Ethernet 1/4, 1.1.2.2, Control V. Then I'll go here, port number Ethernet 1/5, IP address is 1.1.3.2, Control V. Go there, select the HA Ethernet 1/6, IP address 1.1.4.2, Control V. I'll just select this heartbeat. I will set the device priority 100. Okay, because this device priority matters when we are configuring active passive. Okay, so we have done with here. Let me go to into active settings. I need to configure my Ethernet 1/7 as a HA3 interface. I will leave default. Here also I will go with the first packet. Click on OK, and let me just hit the commit here, and I also hit the commit here. Go to into dashboard. Let me open the interface and high availability things. And before that, let me also start my these two routers. Let me start this Linux machine as well. After that, I will also start that one. Just wait. See, HA has been initializing. It is in 99%. So let me just close. It will, and we will watch the status here. See, this device become active primary. And they have not synchronized, so we have to wait while they are. This device is a in active mode. This is also active primary, and this is tentative local status. Yeah, so they are still in synchronizing, waiting for the tentative whole time. So we have to wait. What you need to generally do, just click on sync to the peer. They are just still synchronizing the running config. So see, local status of this device is active secondary, and status of this device is active primary. Synchronization in progress. See, down now they have synchronized. If you go to into your firewall too, and if you go to into network, see, you will not see any kind of IP address over there, but you will get the management profile. So the thing is, you have to configure IP address manually here. Okay, just remember.
So for this topology, you
Hmm.
have to assign, you have to do a management profile for these.
Yeah, we have did this management profile. We want to ping these IP address. That's why.
Oh,
Yeah,
okay, got it.
yeah. And see, I have configured these IP address 115 and 115 on Ethernet 1/1 and 1/2, but these IP address is not synchronized. But if you go to into your device tab, here only they have synchronized the floating IP address. So I have to manually configure these two interfaces. And also if you see, they have synchronized the zone and everything, only the IP part. So I need to configure the IP address. So this is my outside interface. Here I will configure 0.116/24 as per my topology. I am using 116. I click OK. Yes. Now I'll go to into other one, IPv. Then I need to configure the IP address on this interface 192.168.1.116/24. Only that part I need to do it manually here. I'll configure it and let me commit my changes. Now if you see, we are good to go. Our HA is working fine. See, HA is okay, and only the thing is, so we will wait for the commit to complete. Meanwhile, what I will do, let me also configure my this outside switch and this switch and these particular Linux machine. So what I will do, I will open the outside switch, then inside switch, then this Linux machine as well. And let me just start with this Linux machine. So first, and also let me start this one as well. Okay. So what I will do, I will configure on this Linux machine, which you will see Linux 5. I will configure the IP address, which is 192.168.1.100. On this machine, I will configure IP address 192.168.1.200. These the IP address, and mask is /24. And default gateway on this machine, I will configure the IP address of this interface, which is 192.168.1.1117, right? This is the floating IP address, right? So I will this, and on this This interface floating IP address is 192.168.1.118, right? So I will configure the default gateway on that one, which is 192.168.1.118. And here also in this interface also we have configured two floating IP address, right? One is 192.168.0.1117 and 192.168.0.118. So I need to configure the pet rule, right? So on for first firewall, I will configure the pet rule on this IP, and for this one, I will configure the pet rule on this IP for firewall 2. Okay, and we will see the traffic flowing. This is the agenda. So what I will do, I'll go to into my outside switch first. Let me do my config here. Conf t host name. I'll give the host name outside switch 01. Okay. All these three interface I will put in one VLAN. Interface range gig 0/022 switch port mode access switch port access VLAN 10. It's the same config which we have configured yesterday. Okay. Switch port host. Exit out. Interface VLAN 10. IP address 192. Let me 168. 192.168 0 dot. So what IP I can use? I can use any IP address. So let me use here 26. Not 26. I will use here something around 19. Yeah, 99 is fine. And 255.255.255.0. Okay, connectivity is fine. This basically have a switch. This switch have a connectivity with the internet through this one. And now I need to run no shutdown. And let me just also I want to configure one more thing. IP route 0.0.0.0 192.168 0.1 ping 8.8.8.8. Yeah, I can have a reachability till the internet. So this switch is ready. Okay, now I'll go to into my inside switch and I will do the configuration on that one. Enable conf t interface range gig 0/02 3 because it's have three interfaces 1 0 0 then 0 1 0 2 and 0 3. I'll select all of them. Switch port mode access switch port access VLAN. Here I will just use the VLAN 100. Then switch port mode switch port host and exit out. Now interface VLAN 100 IP address is 192.168 1.99 255.255.255.0. Okay, and no shutdown. Exit. I will not configure any default route on that one. For now, let me change the host name, which is inside switch 01. And let me also configure one route. I will configure the default route towards the Palo Alto 1 it was the first firewalls first time. Okay, so the floating IP address first firewall is 192.161.117, and also what, and so I want to enable the telnet on this one. So what I will do, line, I will first use user, add username test, privilege 15, and password is cisco, line bty 024, login, local, transport input, telnet. I have enabled this telnets for doing my test. Okay, let me save my changes. So this switch is ready. Now what I need to do, I need to configure these two Linux machine as well. So first I'll configure my Linux 5 machine where I will point the default gateway towards firewall 1. So Linux, I'll go to into Linux 5, go to into this control panel. I will go to into network, and here I will configure the static the IP address from this node. Then here I will give the IP which is 192.168. 1 dot, what IP address I can use? Let me use here 100, right? On this switch, what is the IP address I'm using? So IP interface, it's 99, I hope. Okay. So I will use here 100, okay? Default gateway is 192.168.117, which is the IP, floating IP address on my first firewall. Name server is 8.8.8.8 and 4.2.2.2. These are the DNS server. Apply my changes. And I'll just minimize it. And let me also go to here. Let me also close this one. And if I'll go to into the terminal, and if I'll hit the ping to 192.168.1.117, so I can able to ping. If I'll ping 192.161.8, one ping to 1.8 is also fine. If I run so arv, let me just check arv-, there is a one command. Let me just increase this size. So at least we are having connectivity, right? Now what I will do, I will go to into this Linux second, and I'll do the same thing. I'll go to into control plane, and I'll go to into control plane, then network, then here I'll configure 192.168.1.200. This is the IP address. Mask is 192.168.1.118. Name server is public DNS here, and just apply your changes. Close this one. Let me open the terminal. Let me try to ping. Let me try to ping to 192.168.1.116. So 116 is reachable. 1117 is also reachable. 1118 is also reachable. Means all the Palo Alto IP addresses are -8. That's the I think command. If you see, when you hit the ARP, you are getting the MAC address, right? So this is the MAC address, virtual MAC of your firewall 1, virtual IP address or floating IP address, and this is the MAC of your firewall 2 floating IP address. Here you are getting the same information, okay? 1117, and you will also get 1118 in some time. Okay, so these devices also ready. If you see, if I try to Google it, I will not able to send any kind of Google will not work right now. The thing is, it is not working because let me just increase the size of this one. Because on the firewall I don't have any net rule and policy. So what I will do, I will first configure the net rule. Okay. So to configure the net rule, I'll just give firewall 01 pet rule. Okay. Port address transfer. Define the sources. Source zone is inside. Destination zone is outside. Interface is 1/1. IP and everything I leave default in translated. I want dynamic IP and port number and translated interface IP Ethernet 1/1. Here you will get two IP address. Here we will get the floating IP address. Why I'm not able to sheet it? So what I can do, just give me a second. Let me just see what is the floating IP address I have configured here. 192.168.0.117 and 0.118. Okay. So we need to basically configure that net on this floating IP address. Okay. So what I will do, yeah, this is the floating IP address as per this diagram. As this is the like active with floating IP address config. They have not shown any configuration regarding the net, but this is the way. So what I will do, I'll go to into the firewall. I'll just put Ethernet this one IP address. Okay, I have to select this floating IP. That's fine. Then I will get both the floating IP address. So I will first configure with firewall 01, and in this one active HF, and this floating I this net rule we are want on the firewall one. So I have used here device priority 0. Click on OK. Let me just clone this one right away. Go there. So firewall 0 to pet rule. This information is same. This information is also same. Only the I need to change the IP address and the device priority, which is 1. So we have configured the net, right? This rule is for firewall 1 and IP address is 192.160.17. And this pet rule is for firewall 2 and IP address is 192.160.0.118. I'll go to into security and I'll add here one security rule. So what I will type here, allow all. Let me add one rule which is allowing all the traffic. Zone is any, destination zone is also any, address is any applications, any services, just allow the traffic. This will basically allow the traffic. These policy and net configuration we only need to do on the primary. It will automatically sync into the secondary. Okay. You will see these details after some time. Invalid floating IP address this. Fail to parse the net policy. Okay. So commit has been failed. So what I can do, I'll go to in this device 192.160.0.118. If I'll go into this one, then HA 10, then 20, 20, then 10. Let me just see. Okay, this is 10, then 20. This is correct. Floating IP bound to the active primary device. Okay, IP config from here it is looks correct. Hmm, then 15 and here we are having 16, right? Okay, that is also correct. Now I'll go to into this firewall one policies, net policies, and let me see. Floating IP and I'm getting here 17. 17 I have bind with the primary. This is for second firewall. Inside, outside, all these things are correct. This we have bind with the other device, okay? Looks good. Let me just commit once again and let's wait. This is active secondary, this one is active primary. This config looks good. Let's see. Commit is failed, invalid floating IP address 192.160.1118. 118, okay. Okay. So the thing is, what I have did here looks like when I am using the when I am configuring the pet rule, when I am using the interface, okay, when I have used Ethernet 1/1 in my net rule, that time basically it is not able to parse the first rule. What happens? Maybe this issue is happening o- due to bug on the OS operating system. Maybe it's a bug on the operating system. Okay, just remember, because if you see as per this particular document also, we have followed the same instruction whatever they have mentioned. Okay, and when we are using this interface address, when we are defining this interface, that time it is failing. So what I have done here, I have just, instead of using this option like interface address option, then the floating IP address, what I have did, I have just directly used the translated address, and I have defined my first floating IP address, which is 192.160.0.17, and I have bind with this with my first firewall. And for firewall 2, I have just translated the traffic on 192.160.0.18. All the details are same. If you want, you can define your zones as well. Okay, that's not a issue. I have changed it that one. So what? Let me just define these ones, and I have bind with this 0/0. And if I'll go to this one, let me just bind my zone is inside. Okay, I will not define my interface here. Okay, because we are getting issue with the interface. I'm not sure what is the bug they have, that one. Let me just commit my changes, and commit will succeed this time also. Last time commit will failed when we have used Ethernet 1/1 on my source translation tab. So just try to use the, you try to avoid using this one, directly define the translated address, and this commit will succeed. Okay, and these rules, basically this rule and this security rule, you will see in your secondary firewall as well. So if I'll refresh this, see, you will receive these two rules here, and the security policy is also there. Now what I can do, I am also configuring telnet on this particular router, this particular outside switch, and we will, after that I will take the telnet and we will see enable conf t. Let me add username is test, privilege is 15, and password is cisco, line vty 024, login local, and transport input is telnet, and right ma'am. Okay, so let me just first do the basic test. This is my outside switch and this is my inside switch. This is outside. Let me also open my inside switch. This is my inside switch. Right now, if you see, so IP route, right now, this particular switch pointing the traffic towards 192.168.1.117, which is the floating IP address of my first firewall. So what I will do, I will just initiate a telnet to this particular outside switch. So IP interface brief, IP address of this switch is 192.168.0.99. 192.168.0.99. I'll get the access. I'll put the password here, test, and password is Cisco. If I run this console users, here I will see the IP address, floating IP address of my first firewall, which is 192.168.0.17. See, means for this particular data, first firewall is basically initiating the session. Means first firewall basically handling this particular entire session. You can also run who. You will also get the same details by running this command as well. Okay. And let me also take the access of my firewalls 115. So for primary, and we will see the session owner and session setup. Admin. Let me take the new and 116. Admin and admin. So if this time if I run here, so session all, I'll do see these many sessions. Okay. So if I'll see the session for telnet, which is the session ID 48. So if I'll go session ID 48, and what I'm looking for, I only look for the s- session owner. Right now, session owner is true, which means this firewall is a session owner for this traffic, and this firewall is also a session setup. Means when we have configured the HA by using the, because both these things are true, right? Session owner is true and session setup is true, means this is the firewall which is handling the entire layer 2 to layer 7 functionalities. Okay, if I'll go to into this one, show session all, and if I'll go to into that session ID, which is this one, so session ID 49. If you see, session owner for the device is false and session setup. So for this particular session, basically primary firewall is the session owner, because if you remember, when we have configured our HA, we have selected session owner election is happen on the basis of first packet, and session setup happen on the basis of first packet, means whoever receive the first packet of a session, he will become the session owner, and session setup means he is responsible for layer 2 to layer 4 functionality and also layer 7 functionalities. Okay. Now if I'll go to into this machine, and you can send any kind of traffic. If this time I will try to open the google.com, I can able to do that. This data basically go via first firewall. It will take some time because these are the VMs, so they always take some time to send the data. And the thing best part to check this thing easily, what you can do, let me just try to find out the terminal. In this terminal, if I'll hit the ping to google.com, ping to www.google.com, they can able to ping. Otherwise, let me see, ipconfig IP is 192.1.100 and the default gateway route minus n. This is the command which we use for default gateway is, they are not, yeah, 1117. Okay, 117, sorry, route minus n. Here you will get the default gateway 118. Okay, and that data will forward. Let me just go to into the firewall. If I'll hit the show session all, I'm not seeing any sessions as well. Okay, but they have a reachability 192.168.0.1117. Okay, they are also not able to ping. Sorry, dot 117. Yeah, ping is fine. Ping is working. Then why they are not able to reach 192.168.0.1? Even though they are not able to that IP address as well. Why they are not able to do that? Because if you go to into your firewall and we have forget to add the default route, you will not see any default route over there. Static route, no default route. So what I will do, let me add one default route. We have add the policies, we have add the net, but default route is missing. So let me add the default route here. Interface is Ethernet 1/1. Next hop is 192.168.0.1. Commit. Okay, let me just commit my changes. As soon as commit will complete, they will able to communicate. Let me run the ping for google.com. See, they have start pinging to Google, and they will also able to open the Google page now. See, so this is the way how we will basically configure the active mode. And if you see this time, if you go to into your firewall, so session all, you will see so many sessions. So if you just pick this session, show session ID 100, and see for 100 we have set the default gateway towards the primary firewall. So for this firewall, he is the session owner and he is the session setup for this one, for this traffic. But they are synchronizing the session with each other. Okay, because you will see the same session also in the secondary one. You can see that session as well here. And if you pick the session for 200, which is this one, and if you run the command which is show session ID, and let me just take any session 175, For this traffic, session owner and session setup is this device. True. And they are hit. This firewall is basically using the pet rule too. Okay. So now what I can do, let me just change the functionality little bit. If I'll go to into my device tab, okay, and I'll add it here. I want the session owner. So when I'll select session owner selection, primary firewall. And if I'll go there and if I'll change the setting over there as well, session owner selection on the visual primary, which means this is a active and passive scenario. Always your first firewall is only able to handle all the sessions. Okay, just let's see. Let me just commit my changes and we will see these things. I will run that session commands and all. And meanwhile, what I will do, let me stop the ping from here. Let me close this session as well. I'll go to into that machine as well. Let me stop the ping and let me just open one tab and let me close that tab. Okay. Commit has been completed. Commit has been completed. Okay. Now let me go to into these firewalls and let me clear all session. Clear session all. It will clear all the existing sessions. Clear session all. And if this time I'll go to into my these machines, if I'll type here www.google.com, see, and on this one as well, www.google.com. See, I'm able to open the google.com. If I'll go to into my primary and secondary both firewalls, if I hit here show session all, so let me pick the session for session this one. This is the session for 192.168.1.200. Okay. So session ID. If you see, session owner and session setup is this device, primary device for the traffic which is coming from my 192.168.1.200, which is the this Linux 6 machine. And this Linux 6 machine is sending the traffic to this guy. When this particular file is sending that particular session detail through the Ethernet 1/7 to this firewall, and this firewall now handling all the data, and he will forward it the data traffic back to this one. Then in this way, this traffic is go. So if I'll go to into that one, let me see which net rule is it hitting. Okay. See, it is hitting the firewall one rule. So what happens? This device sending the data to this firewall forwarding the same data to Ethernet 1/7, then this firewall processing the entire packet. So when we select that option, which is primary device, which means this is a active passive deployment. Okay, so don't select that option when you are deploying active scenario. Now go to into first packet. So we will have that first packet. Let me select this time IP modulo option. So means sessions whenever this particular firewall receives the data, he will basically take the decision on the basis of IP modulo. So they will calculate the modulo. Okay. So let me just click OK and I'll go there and I will also change that thing to the first packet. So sessions owner always be a first packet when he receive, but so we have IP modulo or IP hash or a primary device. We can also select this option means primary device means always primary device will be a session setup here also. So generally we most of the time we will go with the first packet means when whatever device receive the first packet he will do all kind of functionalities. because in that case we don't want to we don't want unnecessary traffic flowing from the firewalls. Okay, but here let's use a first packet then IP modulo. We will also have a IP hash. So here decision basically we will take on the basis of hash value. So first go with IP modulo. Okay, here also IP modulo. Okay, commit the changes and we will see. Commit the changes here. If you want, you can see the details like Palo Alto active IP modulo meaning. They will give you the theory. Okay, so here you will find all the details. Then we have session setup. So on the basis of IP modulo, the firewall distribute the session setup loads based on the parity of the source IP address. This is the deterministic method of the session setup, which means let's suppose I'm having IP address 1.1.1.1. So total parity of this is a 4. If I am having 1.1.1.2, total value is 5. So this first packet, the that packet is handled by the firewall 1, this handled by the firewall 2. Or they will take decision on the basis of I think even number and all. Okay. So I think odd number always handled by the primary firewall and the even number always handled by the secondary firewall. This concept also similar in like when we will see the R load sharing. Okay. When we use the hash value, the firewall uses a hash of the source and destination IP address to distribute the session setup responsibilities. The active prime firewall always set up the session. Only one firewall perform all session setup responsibilities. First packet, the firewall that receive the first packet of a session perform the session setup. These are the things. So if you want, you can just read these things in details. You will get the proper idea. And if you see, that's the basically way this file sending the traffic. In this way, maybe it is flowing through this HA interface, then they are forwarding. Okay. But generally we use a first packet if we are using. But if you want, you can use the these methods. But the thing is the one problem in this particular scenario, let's suppose your traffic is coming received by this firewall, right? He is receiving, then this firewall performing all the session setup things. Then he is just forwarding back to the traffic and he is just sending to us the server. Maybe sometime there is a one issue with the TCP traffic because you have to bypass the TCP session bypass problem. That problem you will face in that kind of issues. S- So what happens? Let me just take one more example. Click on next. So these are the multiple example for this one as well. Okay. So let commit is completed and this time we are using IP modulo, right? So what I will do, I'll go to into my machines and I'll just close this one. Let me minimize this one. Let me open the browser once again. Okay. I will go to into the same this machine as well, and I will just close this one and go to into both the firewalls. I will clear the session, clear session all, and this firewall also I need to clear session all. Now let me just reinitiate the sessions again. Let me open the google.com on my Linux. Not Google this time. Let me open facebook.com on this one. Okay. And here I will open www.amazon.in. Okay, and if I'll go into my both of my firewalls, and if I'll hit the session, show session all, show session all. So if I'll pick the session for 100, okay, for Facebook, which is a session ID, this one, so session ID, this. The traffic which is initiated by this machine, who is the session owner this time? Session setup done locally and session ownership also done locally. Okay, and let me see the session details for other one for 200 traffic. Let's pick this one ID this. Session setup is true. So means for this particular traffic, session setup is done by the this firewall and session owner is this one. Session owner is false means session owner is done by this firewall for the traffic which is initiated from 190 to 160 second machine. Because if you remember, we have configured session owner is first packet. So the thing is what happened, this machine sending the traffic to this firewall forwarding this traffic through Ethernet 1/link to this firewall. Then this firewall do the session setup, forward back to again here. Then this perform the all the layers functionality and he forwarded out. Why basically session owner is same for both the devices? This firewall, because if you remember, we are using this particular range 192 168 1.100, right? This is a even number, this is a even number, this is a even, right? But this is a odd number, so overall value for this IP, the parity value is odd, right? For this one is also parity value is odd. And for odd numbers, always primary firewall basically handles the traffic. So what I can do, if I'll go to into my switch, inside switch, because inside switch having IP address, it's also having IP address, which is, let me exit out from here. Okay, this session is hanged because I have enabled the telnet. So what I can do, if I'll go into outside, disconnect, question mark, 0, 1, because from here we have done the telnet, right? So let me just duplicate the session and I will close that session. Until this firewall release that session, until you will not see. Okay, so what I can do, if I'll change the IP address, let me change the IP address on Linux machine 6. I will change the IP and I will configure something different IP address. Okay, Right now it's have a 192.168.1.200. I will configure 201 and then we will see. So what I will do, if I let me just find where is these things. Let me first minimize this one and let me just change the IP which is 201. Okay, and I'll just apply config sudo ifconfig. So right now we have config IP which is 201. Okay, and if I'll go to into the browser and this time if I'll type any website www. Let me try to open example.com and we will see the session for 201 this time. Let me try to open one more website www.cisco.com. Okay, so things are going here. Okay, default gateway also changed. I need to set the default gateway 118 only because we have modified IP address, so it has modified this one as well. That's why. See now we are able to open this one and we are also able to open cisco.com. Okay, and if I'll go to into my any of my firewall, okay, and if this time if I'll change your C session all, let me just pick the session for 201, this one. And for this session owner is the second firewall and session setup is also second firewall as per my knowledge. So session owner is false, but session setup. So session setup is done by this firewall still, but the session ownership is done by the other firewall who is receiving. But this time it should change, right? This is the IP address. Okay, clear session all. Let me just clear all sessions. Clear session all. So I have clear all the sessions. Okay, www.gmail.com. Let me just try to open that one. Show session all. Session setup is done by the locally with the firewall one, and but session owner is the other firewall. So all the session is handling by this firewall only. We have done here IP modulo. This one also IP modulo. So maybe I'm not sure how they are calculating this parity value. Okay. But that's the way how they are just handling the traffic. So now if you want you can change the things because they have mentioned like they have not mentioned that exact algorithm right for session owner. So session setup, they have not mentioned the exact algorithm how they are calculating the modulo value, IP modulo value, right? If you see here the 5 distributed session setup load on the is a parity of the source IP address, but we are not sure how they are calculating this parity value, right? Palo Alto, let's see, parity Palo Alto firewall IP address parity calculation, but maybe I'm not sure they will give you anything regarding that. No, they have not mentioned anything how they are calculating the parity value and all. Okay, nothing. So no worries. Now let me move on and let's see the another method, which is on the basis of IP hash value. So they will create the hash value on the basis source and destination address. Okay. Generally we will use that method for if we are using hash method, then we will go for always source and destination. Let me commit my changes. Let me hit the commit here as well. And this time let's see how they are basically dealing with the sessions. Then this commit is also completed. Okay. Now if this time I'll go to into my machines, and if I'll open any website www.gmail.com, then www.yahoo.com, portal.azure.com. I opened these few websites for my Linux machine 6. Okay. And let me just pick 2 3 sessions for this machine. Show session all. So let me pick not this one. Let me pick that session number, this, and we will see the detail. So for this particular session, this is handled by firewall 2, and the session owner is false, means this local firewall is doing the session setup. Okay, for this traffic. If I'll pick another value which is for SSL traffic for this IP address. Okay, so session setup and session ownership is false for this one, which means this particular session is handled by the secondary firewall. Okay, so this is the way how they will basically share the session, how they will basically take the decisions of session owner and session setup. Okay, now the thing is, in basically HA, the last part, which is like ARP load sharing. In ARP load sharing, what happens, they basically share the load on the basis of ARP table. In this, a single IP address is shared between both the devices. So these are the two devices which we are having. Is a router where here ARP load sharing would not work. Okay. Unique MAC address for each interface supporting the shared IP address. Means this is the IP address which they are sharing with each other. Devices respond to the client ARP request based on the source IP address, means whatever source IP address is there, they will basically reply for the ARP on the basis of that. Requires a layer 2 connection device. So what I can do, because here you will see we are having layer 2 kind of deployment here. So what? Let me do one thing. You know, we have configured the telnet on this firewall, right? On this particular switch. So what I will do now, I will basically try to access the telnet of this switch from this switch, and let me enable the R plot sharing here, and I will use one of the IP address, which is 192.168.0.189 for R plot sharing. Okay, for the R. So how we can do that? Let me just show you that part. We go to into this firewall. I click over there, and what I will just change this method. We will go with the first IP, first packet. That's the here also I will go with the first packet only. Okay. So here I have set the method. Here I have set the method. Or not first packet. Let's make it the default one, which is on the so IP hash. Here also let's make it IP hash. We don't want to change that thing. Okay. Just make it default one. Only the thing is, just add one more IP address here. Interface is this one. Add IP address 192.168.0.189 slash 32, and click here R load sharing on the Visual IP modulo. Okay. You can also use hash, but I will use first IP modulo. Click on OK. Okay. Ethernet 1 is already in use. Okay, why it is giving me this floating IP? This one. Okay. Ethernet 1 slash Ethernet 1 is already in use. So what we need to do, we need to actually remove these floating settings, I hope. Or let me just go to into Ethernet 1, and I will add here. Okay, not need to remove. I will add the IP address here 192.168.0.189 slash 32. Click on R load sharing on this IP module. Click OK. Now I'll go to into this firewall as well, and here also I will do the same thing. Add 192.168.0.189 slash 32 upload sharing, this one. Okay, we have done that config. Now what I want to do, let me just create one net rule for accessing this server, this particular switch from outside network. So I will create one destination net. Just remember, we'll just give the name to this one, destination net. Original source is on outside, destination zone, source zone is outside, destination zone is inside. Okay, and destination address is 192.168.0.189. Translated packet Translation type is dynamic IP with session dynamic IP. Then here I need to define my address, which is 192.168.1.100. That's the IP address of my server, right? In binding, I need to select both. Okay, that is correct. Okay, everything is looks fine here because on outside we don't know source. So source is any, destination is the public IP address, and translated address is the private IP address. Okay, and what I will put this rule into first place. Let me just commit my changes and let's see. If you see in that one, here you will also get the example for this particular use case regarding ARP load sharing. This is the example for ARP load sharing. Just if you want, you can check these docs, okay, while you are configuring. This is the particular IP address which is sharing the load. In that case, basically default gateway is also the same IP address 192.162.100. So if you want, I can also configure one basically low ARP load sharing IP address here. Okay. Let me also, so this is for destination net. Let me just test that scenario, and after we can check it out the other one. Okay. If I'll go to into my outside switch, this is my inside switch, and this is my outside switch. Okay. Let me just go there, enable. Let me just check what is the ARP I'm having. So I don't have any ARP for 189. Okay. What I will do, I will hit the telnet 192.168.0.189. Let's see telnet will work or not. Telnet is not working. Let me see what is the IP setting we are having here. It is just pointing towards 192.168.1.117. So IP route. It is having one route. So ARP, let me see. So 189, if you see right now, ARP is giving by this IP at 001. Let me see the MAC address. So MAC address table, and this one 500.002. 001 is on this interface, and 001 giga 0/1 interface. So this is the IP address which is responding for the ARP right now. Why this session is not working? Because we need to run that command, okay, on the firewall. Let me just go to into configure, set device config system TCP. Let me just see TCP. we have to bypass the TCP states. So service disable telnet node, this one. Okay, no. So there is a one command which we need to use, that command for disabling the TCP details. Route systems, then settings, device config, then settings. In settings, you will find TCP. You have to define. So these are the settings which we can. So what we need to define, asymmetric path. We need to bypass the asymmetric path. Right now it is dropping the traffic. Let me just commit my changes. This thing I have done on primary, I need to also do on the secondary. So that's why I don't use this ARP sharing and all, because I need to basically change the firewall functionality as well. Set device config, settings, TCP, asymmetric, path, bypass. Commit is pending. Okay, because we have run that command on this one, so just we have to wait. Now let's commit. And if this time if you will basically go to into your outside system, if this time you will do the telnet, this time telnet will work. Let's see. It should work. Otherwise there is some other issue. Okay, so interface IP brief. So IP interface brief. Otherwise we also need to do some other changes. We will see that one. I need to create one more ARP sharing IP address in for my inside network, and I will point it out the. So show ARP. I am getting the ARP 189 from this guy. Okay, and what I will do, let me go to into my device tab once again. Okay, and I'll go to into this interface, and I need to add one more IP address, which is 192.168 one dot. Let me add 189 here slash 32, this one and this one. So I will use this one for ARP load sharing into my inside network. It will automatically come here, so I don't want to change the settings here. And let me commit my changes. Commit is still pending here as well. Let's wait. I think we have forget to commit our changes right after configuring these settings, because we have one destination net rule. Sync in progress. Okay. Okay. This setting is come here. This setting also come here. Okay. That's fine. Now let me go into my inside switch, and what I just want to modify my default gateway. So do so run section IP route. I need to remove the route from here. So the thing is, generally we either use one method. Either we can go for ARP's load sharing, or either we can go for the 189. Either we can go for the rpload sharing or floating IP address. We don't use both at the same time. Okay. Now, if I'll go to into my outside again, let me hit the telnet. Let's see, telnet will work or not. If it did not work, maybe there is some issue with the net. Let me just check. Traffic is coming from outside, going towards the inside zone. That's the public IP address. 192.168, 1.100. Let me just see. It's not working. I have just modified it little bit. Let me just commit my changes, and his IP address is correct here. So IP interface believe which is 100 only. Okay, that's the mistake. IP address is 99. And we are in our rules, we are using here 100. Always that was the mistake. So let me go with static IP this time, and this time it should work. Okay, it should work. So we have done that mistake last time. We have just added the wrong IP address here. So commit is completed. Let me just go to into my outside, try to do the telnet. Still not working. Okay, can I able to telnet on to 192.168.1.100, which is the IP address of this machine? So IP interface brief. This also have 0.99, right? 0.99. Yeah, I can able to telnet on that one. I'm getting so many messages for the log test and Cisco. Mhm. I have enabled the debug, so I'm getting the message continuously. But this time we have logged in with 192.168.0.117. This one, and so ARP, if I'll see, we have ARP details and everything here. So right now I'm on inside switch, right? And if I'll undebug on all, okay. If I run the show ARP here, so we have configured 189, which is right now handled by the second firewall. If I'll go to into these machines, and let me just change my default gateway setting. So what I will modify my default gateway, and I will configure here 189. Just apply my changes, and I'll go into fifth machine as well. I'll just expand this one. Let me just close all these things. Open the control panel, network tab, and let me just change the IP 192.168.1.100 and default gateway is 189. I will apply the changes and I'll open the browser and open www.google.com. Same from here. Let me just refresh these things once again. I'll go to into these devices. If I run here, exit out, show session all, we will have few sessions here for DNS and all. So what I can pick some kind of Google traffic or something else from this first machine. So let me just check the ARP as well. So session ID, this one. So if you see right now, this packet is handled by this firewall only, the primary one. Okay. And if I'll go to into this machine, if I'll type here ARP, then we will get the ARP who is responding for the ARP. So this one also, and this is my fifth machine. Oh, let me close the browser. Let me open the terminal. Let me see the ARP here. So right now for this device, R41, we are not getting the R for default gateway, which is 189. I want the R for that one, this 189. Still, we are not able to see any R for that IP address. How it is possible? 99.115, but we don't have any R for this 189. And this is the IP address which we are using into our 192.168.1.189, right? IP address is correct, then why they are not sending resolving to the R? Okay, maybe that's the issue due to something. So what I can do, let me just check. This is the use case actually. This is the like shared IP address and both the devices putting the default gateway towards that one, right? So these firewalls only reply for the ARP on the basis of IP modulo. Ping to 192.168.1.189. Let me just ping. Yeah, I can able to ping this IP address. And let me just hit the ARP table. This time this ARP is resolved by this IP address 500.0.00002. And that's the primary firewall. Let me go to into that one. Let me directly ping this IP 192.168.1.189 and we will see the ARP. So ARP, not so ARP, it's ARP only. For 189, this time ARP is resolved by the firewall 2. So you see right here ARP resolution happens on the basis of IP addresses. Okay. This machine sending the traffic towards the first firewall and this machine sending the traffic towards the second firewall. Okay, so here basically our resolution happens. Now if I'll change little bit here, if I'll go to into this interface, into this sharing, and if I'll use your IP hash value, click OK, click OK, and let me commit my changes. We will see why this destination net is not working with this IP address. 92.161.99. Okay, so what I can do, see commit has been completed, and for this interface this will not change. Yeah, change the value IP has, right? So if this time I'll again go to into these two devices, these two machines, and what I can do, let me just first change the IP address of both the machines. Here I will put like 2, this one is same 189. Let me just change 189. I'll just save it. Here also I will change the IP address. I will use here 192.168.1, and I will change the default gateway to 189, the ARP sharing IP address. Here click OK. Let me just ping. This time is ARP is on from coming from 1. Let me see what is the ARP setting. Generally that ARP caches have a timer of 300 seconds. So after that only they will flush that ARP table, and I don't know the command to clear the ARP on this Linux machine. When we clear that ARP, then they will send the ARP again towards the firewall. That time basically we will get the proper idea. So no ARP cache. Let me ping to 192.168.1.189. Ping is working. Check the ARP. So for this, ARP resolved by the first firewall, right? And for this also ARP resolved by the first firewall, which means here they are sharing the load on the basis of ARP now, right? They will create the cache and they will reply to the request. So when firewall send the traffic, they will reply for the ARP, right? And on that ARP, maybe they may first firewall reply or maybe second firewall reply, right? On the basis of this hash value which they will calculate. Okay, let's see that thing on a sessions. So session all. So I'll have open the Google base. So what I can do first, let me clear all this and clear session all. Let me just refresh it now. So session all. So there is a one session for Google base. Let me just, this session is initiated by 192.161.1, which is the Linux 5 machine, this machine. So session ID, this, go to here and see this traffic is totally handled by the first firewall 1. Okay, and if I'll check the session now, let me just check the session for which machine? Let me go to into the other machine and let me just refresh these ones. Refresh here. I will refresh to the Gmail as well. And let me just hit the show session all. So Yahoo traffic we have seen. So if I'll go to into this machine, show session, session ID, this one. This traffic is also this traffic is handled by the for session setup. This is not, but this is the firewall who is a session owner. But session setup is done by the other firewall. And if you remember, for both of these firewalls, who is responded for the R? He is the like first firewall because this is the MAC address of first firewall. Just remember, this MAC address is available on primary firewall, this firewall. Okay. So I'm not sure if there is any command. So MAC, let me see. All this is for layer 2. So interface all. This will basically give you the IP details and also MAC address details. See, on Ethernet 1/2, which is the inside interface, this is the MAC address, right? And this it's a similar MAC address, right? If you see into your this place, right? This MAC similar, which means this firewall is responding for the MAC address, means for the ARP address. That's why this firewall become the handling that particular traffic. That is the reason he has become the session owner, because we have configured first packet is the session owner. Okay, so here load sharing happens on the basis of ARP table, on the basis of ARP traffic. Okay, so this is our active deployment into floating IP and also in ARP sharing mode. If you have any doubt, anything, then let me know. Otherwise, we are good to close. Yeah, this lab will become little bit complex. Yeah, it's a complex lab only because there are so many things which I need to cover. So there is maybe somewhere you will find some complexity, but try to follow the lecture, try to do the lab. That time you will able to understand the properly what I am trying to do here, and also just go through with the use cases. Just read through them. You will get the proper idea.